What is a main effect and what is an interaction effect? So what we've been talking about up to this point with just one independent variable, one dependent variable, is most likely a main effect. In fact, it is a main effect. So here on the left we have a graph showing the strands of spaghetti poured depending on the size of the box. So you get a small box of spaghetti and it doesn't have as much spaghetti in it. A larger box of spaghetti would have over 300 strands of spaghetti poured in our silly little example here. So we have one independent variable, which is the size of the box. This independent variable has two levels. We have small box and we have large box. So two levels in our independent variable, the size of the box. The dependent variable, and remember the dependent variable depends on the independent variable, is the strands of spaghetti poured, so the number of strands of spaghetti poured. So we're saying here we would probably have a hypothesis that we would pour more spaghetti from a large box than from a small box, which is exactly what we're looking at. This is a main effect of the size of the spaghetti box on the strands of spaghetti poured. Simple, straightforward, the size of the box will affect the strands of spaghetti that you can pour. Here on the right, we have a study looking at driving distractions when you're on your cell phone, right? So we have one independent variable, which we're calling cell phone condition here. So there are two levels of this. One condition, you're on the cell phone. The other condition, you are not on the cell phone. Our dependent variable, braking onset time, so the amount of time it takes you to brake. So that's our dependent variable. We're saying that it changes or depends on the independent variable, our cell phone condition. So here we can say when you are on your cell phone, it takes you longer to brake than when you're not on your cell phone. Again, these are main effects. There's one independent variable, one dependent variable, so we just have a main effect of that IV on that DV. Now when you start adding independent variables to the mix, so when you have more than one independent variable, you can get to see this thing called an interaction. And so what this is that one level of the independent variable is combining with another level of a different independent variable to have a unique effect on the dependent variable. So let's consider an example of an interaction. So returning to the example that we used a second ago, we had an independent variable cell phone condition that had two levels, so either you're on a cell phone or you're not on a cell phone, and we wanted to know the influence of that on braking time, which was our dependent variable. Here, when we're considering an interaction, we add another independent variable. In this instance, we're using age, so we have two levels of this independent variable again. We have younger drivers and we have older drivers. Now we'll have, because we have two independent variables, we will have two main effects. So we have a main effect of cell phone use on braking, and we also have a second main effect of age on braking. Now main effects allow you to ask questions like what is the impact of cell phone use on braking, or what is the effect of age on braking. With interactions, we can actually ask a slightly different question because these levels of our two independent variables can be combined to actually create four cells of people. So when we combine these two independent variables, we'll have a group of people, a group of younger drivers on their cell phones, a second group, younger drivers not on their cell phones, and then we'll have older drivers on cell phones and older drivers not on their cell phones. So with these groups, instead of simply asking, is there an effect of cell phone use on braking time, and or is there an effect of age on braking time, we can actually say, does the effect of cell phones on braking time depend on age? So maybe we do have this effect where when you're on your cell phone it takes you longer to brake. What if that was only true for younger drivers? Now, I doubt that in the real world it would play out like this, because what we know from cognitive psychology is that we really can't multitask. So please don't think I'm telling you real research results here. But maybe younger drivers on their cell phones actually do just fine and can drive just as well as every other group not on their cell phone. So they're just like a typical driver. Maybe older drivers on cell phones are particularly bad and their brake time is way, way, way up there. So maybe, they're experienced drivers, but they're not familiar with the technology, and so they have to fiddle around with the phone and all of those good things. Whereas younger drivers, I think some of them could probably text without even looking at the phone. So that's what an interaction effect is. So it allows you to ask things like, does the effect of cell phones depend on age? Main effects would just say, is there an effect of cell phone use on brake time? Is there an effect of age on brake time? But with interaction effects, we can combine those levels of the independent variable and say, does the effect of cell phones depend on the age? So hopefully that clears up the interaction issue at least a tiny bit. Now remember, this is some really complicated stuff. You'll hit this again really hard when you take statistics. The purpose of me covering these advanced topics in this class is to start you to start thinking about it, start kind of chewing on it, mulling it over, thinking about it, start getting comfortable with these kinds of things so that you'll understand it much better later on. So we'll build upon this idea of interactions not only in this course but also if you go on to take statistics. So if you don't completely understand it but you just have a gist understanding, you are exactly in the right place.